Okay, so for today, we're going to continue with data visualization with Leafmap. In the last lecture, we have covered about vector data visualization, and we briefly mentioned about raster data visualization. And today, we're going to go through all examples in depth how to visualize raster data. So if you're doing GIS, remote sensing, most likely you want to encounter either vector data or raster data. And raster data, think about it, now a lot of data actually in the cloud. You might also have some data on your local computer. So you want to encounter this one way or the other. And this lecture is going to show you different ways to visualize data just with couple lines of code, 2 to 3 lines of code. You can also source data from the internet, and you don't need to download the data. You can directly visualize the data from those so-called open access data repositories. So it's this Leafmap lecture. If you click 14.11, so this will be the last one we're going to cover. And so this one actually has a lot of examples in here. And one thing I'd like to point out, as I mentioned in the previous lecture, so all the website here, these maps should be interactive, okay? So you can actually visualize them interactively. The only thing that's not working is those buttons. So if you click the upper right corner, those things won't work on the website because this is become, after it's being rendered, it becomes a static website. It becomes HTML. There's not a Python kernel behind to actually respond to your clicking, your mouse clicking and stuff. But the zoom in and zoom out, those are like static layers. It still works fine. So I want you to know the differences. Why you want to run locally, because we have access to Python kernel, okay, we do a lot more things. And sometimes some of the data layer might not be perfect, but you see, at least it still works. You don't have to write Python code. You can visualize my result interactively, so at least you can see what is going on, right? So we did this one for the midterm, so you can see you can create this kind of split map easily. And we also want to cover this one. For example, you have maybe do building detection. We cover the building detection maybe when we talk about SAM-Geo. I'm going to show you how you can give a satellite imagery and you can detect the buildings very easily just with couple lines of code. So we will cover that later. And how to visualize, for example, lane cover data, zoom in and zoom out. So these data are all interactive, right? It's couple lines of code. And local raster data, some of the things you will see is being rendered, but the imagery doesn't show up. It's also normal because some of the functionality relies on Python kernel. Some of them do not, okay? So the reason why some of these can show up, because those don't rely on Python kernel. There's a middleman somewhere on the internet that process the data. But for some other functionality, for local raster data set, your middleman is on your computer, is on the Python kernel. So when you render as a website, the Python kernel is gone, it's dead. That's why the image doesn't show up. So it's not something wrong with the website. So I want to make sure that you understand the differences when you are rendering some data. The map may show up or not, but the zooming, the location looks right, but the layer doesn't show up. And you're going to encounter this one sometimes in the future when you're doing coding. Oh, I add the imagery, the it doesn't show up. If the file path is wrong, the URL is wrong, or you are using the wrong functions to visualize the data. So, and for example, you can visualize data from the cloud. You can also source data. You can also access data, for example, from AWS, S3 bucket. So those are basically cloud computing, where the data being hosted, and how to actually visualize the data from there for free. All right, so that's about kind of a brief overview about what we're going to cover. So next, let's get into the coding. And I've updated Leafmap. So if you run into any errors when we are going through the example, probably you just need to update Leafmap. So pip install -u Leafmap, update it to the latest version if necessary. So whenever you run into something, if there's any errors, look at the error message. If say the function is not available, there's some bugs or whatever, try to update it because I'm updating the package every day, not every day, every week. Okay, so if something goes wrong, I might fix it. And so if you install the package like the beginning of the semester, there are certain functionality that won't be available in the lecture. So just want you to pay attention. So and again, this is a long document, so I'm going to use VS Code. Upper right here, there's an outline. If you click the outline on the left side, you should see the table content for this notebook. So I'm going to go to the Oh, by the way, so before you do that, you want to import the library first. So I'm going to import Leafmap. Okay, and then I can skip to the visualize raster data section. No, here. Okay, so overall, for raster dataset, there are two types. Either the dataset in the cloud or the dataset stored locally. Okay, so we're going to cover data in the cloud first. And there's a data format called Cloud Optimized GeoTIFF. You probably have used GeoTIFF before, right? DocTIFF. Like if you use desktop GIS, you might have downloaded some satellite imagery from, for example, NASA from somewhere. Usually nowadays using the TIFF format. And TIFF format is like has a long history, but we have a new one called Cloud Optimized GeoTIFF. What does this really mean is the data format is still the same because GeoTIFF is very flexible. So basically for every file, it has a so-called some kind of header. The header basically indicates how you're going to read the file. So Cloud Optimized GeoTIFF have some additional things in the header. So when you open the file, it knows how to read the file. The reason why it's called Cloud Optimized GeoTIFF, it is because it's cloud optimized. It's optimized for cloud computing, for optimized for cloud retrieval. And the concept is very much similar to when you're seeing Google Earth, Google Map, right? So we are pointing to the file, but we're actually not downloading the entire file. So internally, they have so-called the pyramid, so-called the overview. So for example, your raster imagery might be, let's say it's 1 meter resolution. It's 10 gigabytes. So when you're pointing to the file, you're not downloading the 1 gigabyte all at once. If you zoom in, zoom out, like just getting an overview, it might down some resample that one to maybe 1 kilometer. From 1 meter to 1 kilometer, your file size decreased by 1 million times. So if it is 10 gigabyte, you might only have like couple KB. So it's very tiny. So when you zoom in, the area becomes smaller, the resolution becomes higher. But it's basically we sample your dataset to different resolution, and we are actually retrieving just a small subset of the dataset. Depends on your zoom level and depends on your area. The idea is exactly the same. You are streaming videos on Netflix, or you are streaming videos on YouTube, right? They are all high definition, and the video can be 1 hour, just like you're watching the lecture recording, right? For each video is like 200 megabytes. But when you click the link, it opens right away. You can just stream. So the reason for that is not downloading the entire file all at once. You are basically fast forward, it's going to download those frames, and then you're going from there, it's going to stream the data. So you can think about Cloud Optimized GeoTIFF is for data streaming, data visualization, without having to download the entire file all at once. It's based on a so-called HTTP range request. That means when I'm zooming into the map, it figure out your area and figure out the zoom level. It's going to request just the thumbnail or overview from that data, and then it puts it all together. A small tile. I showed you last time, right? Is under the hood is just like different small sections, and then put it all together, so it looks like become a seamless raster data set. So this is why it's called Cloud Optimized GeoTIFF. Why it's so popular? Because it's efficient for data retrieval and data visualization. Make sense? So you think about it, it's basically streaming data. It's streaming video. This is streaming geospatial data, raster data. And that file has a different level. So you can think about you taking a high resolution photo. Besides that photo, like high definition, it also has like a resample, multiple version, like 1 meter resolution, 10 meter resolution, and then 100 meter resolution. So it basically is just like a pyramid. And then what you're going to retrieve, it depends on your zoom level. It's going to find out the corresponding pyramid. And that file size is pretty small. So you don't need to download the entire file unless it's really necessary. So if you want to learn more, you can click the link here to look at like what is Cloud Optimized GeoTIFF. But it's pretty simple. So pretty much all the file is going to be accessible through an HTTP URL. So you can host the file anywhere on the internet. As long as it's like you can access to the server, then all we need is just a URL, and then we can just use the add cog layer. So the add cog layer basically is add Cloud Optimized GeoTIFF layer, and then you can give a name in here, a layer name, and that's it. So take a look at this one, right? So this is Maxar high resolution data set. I think it's like 0.3 meters. So basically 30 centimeter resolution, super high. If you zoom in, you should be able to see the file. And what you're looking at here, this file is couple gigabyte. But the reason why it's so fast, like there's no way you can download the entire 3 gigabyte within 1 second. So if you run this one, it should show up just within 1 second. Because when this one is loaded, this is a small resample data set. So it may be only up a couple KB, couple megabyte. So it should be fine. So you can zoom in, you can zoom out, something like this. Upper right here, you can turn on this layer control. You can turn the layer on and off. You can also change the opacity. So this one is, you need the Python kernel to run it. Otherwise, it won't work. Understand? So this is the URL. So anytime if you're trying to use the ad hoc layer, and if that the raster doesn't show up, that means usually your URL is wrong. So how do you figure out your URL is correct or not? Is when you click this one, it needs to pop out a window for you to download. If it doesn't do that, if you go to another website, that means your URL is not the right one, because it's not a direct URL. So this one is called the direct URL, means you access to the direct file, direct URL to the file. So for example, I can just save this one. Oh, I actually downloaded it last time. So this one is 2.9 gigabyte, right? It's pretty big. I don't want to download. So you can visualize them directly using this way. I also put this one here. You actually don't need it. So because sometimes when you're adding a raster, you have no idea where is that one going to be located. So the reason I put in here is because when I render the map, sometimes when it's creating a website, if it is too fast, it will not zoom into the location. So for example here, the only reason that I'm doing this is because I want to render to on the website, it zoom into the location. If I don't add that, sometimes it just zoom to the global map. But if you are doing it locally, you don't have to worry about this. So all you need is Leafmap.map. Just create a map and then just give the URL and then add cog layer. That's it. So if I run this one, it's automatically zoom to the center of the map. And so the add cog layer should have that parameter here called zoom to layer. And then by default, it's going to zoom to this raster data layer. If I don't, you can turn it to false if you want to, for example, zoom to layer equal to false. Then by default, it's going to be just a global map. So in this way, this is sometimes you see on the website, if they're like, I didn't set the zoom center, you have no idea where it is located, right? It's somewhere, but it's hard to tell because the area is way too small. It's probably somewhere here. Okay, it's here. It doesn't show up until you find the location. So you want to use the default settings, just zoom layer to true, then it should show up. Okay, makes sense? This is so much easier than using raster IO, right? So how so many lines? This is so much easier to understand. And this is the power of using Leafmap is it's all high-level abstraction. So you don't have to deal with like how to open the data set, how to get the layer. It's just like, okay, create a map. Where is the file being hosted? Your local file path HTTP URL, and then call the function, and then display the map. So this is one way you can add this. And so once you have the data layer, sometimes you might want to see like, okay, this is a raster imagery. What kind of metadata information? So you can call the cog info to look into the data. So it's going to show you the bounding boxes, minimum zoom level, maximum zoom level, the band parameter, for example, B1, B2, B3. Basically, this one has 3 bands, right? And the data type, and the scale, and the width and height. For example, how many pixels? And this is the width, basically how many columns. The height is how many, like, you see, this one is 200,000 rows, right? Because this image is very elongated, so that's why it's so big. So this why this imagery is like 2.9 gigabyte. It's a pretty big imagery. If you just want to see, for example, how many bands, you can do it like this: B1, B2, B3. Sometimes if you handle like multispectral, for example, lane set, you might have B1, B2, B3, B4, all the way to B7. So if you don't want to use the default like B1, B2, B3 for visualization, then you can come to here, add cog layer. It should have the bands parameter. So this one allows you to customize which band you want to show as the RGB. So in this case, I can do it like this. I can say bands equal to, of course, this one is just RGB, right? It doesn't really make sense for us to change it. we can just use the default one, but I'm just showing you that you can customize it. So for example, by default, it's going to be RGB, right? We can reverse it. For example, I can say B3 and B2, B1, okay? Will that work? So the color going to look different because it's not natural color anymore. It looks like this. You notice the differences? Because this is not really RGB. It's reversing. The red band is in the blue channel, and the blue band is in the green channel. But you can also visualize just one band. For example, okay, we have RGB, right? I just want the red is in the first channel. So if you just want the first one, you can just display B1. So in this case, I just want to display B3, right? So B1, B2, B3, red, green, blue. So what's B3? Blue, okay? So take a look at this. See what this, right now it's just one band, right? I'm not sure if you can see it. It's just, right now it's no color, so it's just one band. So it's up to you. So if you have an image that has 7 bands, you just need to see what's the band name, and then you can whatever combination that you want. It's up to you what you want to use. So but if you don't, you're just going to grab the first 3 bands instead. So I'm going to run this one again. So we have this imagery, looks nice, RGB, and I can add another one. So that one is before the file and before the Wi-Fi. The second one I can point to another URL and then add code layer and then give a name, and then I displayed it again. So now I have these 2 data layers show up together, and I can use this layer control here to see the changes of the 2 raster data layer. All right, pretty cool. So they add the split map, not the split map, right now it's just like the layer opacity. And so everything that we're doing here, we can control actually programmatically. So right now, I use the layer control earlier, I used the layer control to change the opacity, but all the data layer that we just added can be controlled using Python code. For example, here, I can type add map.layers, and this one to show you, right now the map has 3 data layers. So you see here, the output basically is a tuple. The tuple, like tile layer, tile layer, tile layer. So all the layer that we're showing here is a tile layer. So for example, you want to access, they say, okay, the last data layer that we added, right now the opacity is 1. You want to change it to maybe a little bit transparent? We can do it like this, m.layers, square brackets. So how to access the last item in the tuple? -1, okay? And then you can just dot. It should pop up at least. So right now we are accessing to this tile layer, and there's an opacity. I can show you here. Opacity equal to, for example, 0.5. So pay attention to the one above. I want to see here. And if I run this one, see what happens. You see that? So everything under the hood can be controlled by our Python code. I can change it back, for example, to 1. See that? I can change it to 0. Then basically it's going to be transparent. I can change it back to 1 again. Oh, 0, 1. I can also do it visible. There should be a visible attribute that whether you want to show this map out, this layer or not. So visible equal to false. Take a look. And now I can go back to this layer control here. You should see this one right now to be turned off. So everything is basically synchronized together. So when I'm turning this one, under the hood is setting those attributes. When I'm changing this one, under the hood is actually calling the attribute, setting the attribute. So this is how it's being done, right? Right now using the interface, but everything can be controlled precisely using Python. And this is, I designed those interface, but I had to figure out how to actually to change the attribute. So you don't have to. It makes it easier to use. So that's about adding multiple data layers, but we can just use a split map. So again, I'm going to create a map and then just split map, left layer, right layer, and then give a label. So the URL, just the HTTP URL. And this is really nice because if you want to compare data layers side by side, this can be useful, right? So I can have the one on the left and also the one on the right. So now I can compare these 2 raster data layers, couple gigabyte, and then just with basically 3 lines of code. And again, this one is not needed. You don't have to worry about where this one is centered or not. It's going to figure it out automatically. So I can just create a map, give me 2 URL, and then just pass it into the split map. And I can give you a left label. The label is the one going to show up in here. And also the right label is going to be the one showing out in here. So pre-event, post-event, and then you can zoom in and zoom out. Okay, so you can actually pointing to the URL to any raster data on the internet. As long as you can find the URL, and then it's a direct URL pointing. If you can click the link and it asks you to download the file, that means the URL usually is the direct link to a file. So this is how you can compare data side by side. And another example I want to show you here. Again, this one is hosted on GitHub. So you can just put the dataset available on GitHub and then give it the URL 1 and 2. Similarly, we can use the split map and then just passing URL, and then give a label. And the additional things that we do here is that you can pass in additional arguments. So additional argument means that you can, by default, it might not be perfect. So for example, if I don't use this left argument, if I run this one, see what happens. The color doesn't look nice. It's hard to see. And also, I added this one here, add base map. So if I turn the base map off, it will look like this. So basically, right now we are visualizing 2 raster data layers, right? This is basically the building mask, the building detection result. And it's a raster imagery. It's a grayscale one. And on the right is the original imagery that I used to do building detection. And now I want to overlay these 2 together. It's actually hard to see, right? Because the data layer is not, the background, the black color is not transparent. So that's why it's not super helpful. And this is what this one is about. So if you need any additional arguments to change the data layer, for example, the left arguments, the right arguments, the left argument applies to the left layer, right? So the left layer is this one, image 2. Image 2 is this one, right? The building mask. And also there's another one, the first one. So you can update it if you want, for example. So now if I change this one, I change the node data, the 0, the black color to 0. That means it's going to be transparent. And also the opacity to 0.7. The color map name, this is the map property color map. So you can change it to anything. So right now, this certainly looks much better, right? And you can zoom in. You can see the buildings, detection result. Again, we cover how to do the building detection later, but at least for now, you can see it looks pretty nice. So you can see the overlay the 2 data layers together. And the color doesn't mean anything. The color is just a unique random color for each object, for each building. And right, so this is how you can visualize the 2 data layer. If you comment out this one, it will look like this. Again, this is also not perfect because by default, if you add just 2 data layers, it's just going to show you these 2 data layers. And so the left one is the building mask, the one on the right is the satellite imagery. So they don't actually overlap with each other. So the trick here is to add the base map, or you can add the raster data layer. I can do it like this. Before you add the split map, you just add the code layer. And then you add image 1, something like that. Like this. You should be able to do that. So in this way, there's always a base map behind. So when you do the split map, then at least the base map is always there. So kind of a little bit awkward, but if this is what you really want to use, is that you want to overlay the raster data layer on top of another raster data layer. Okay, any questions? And so for this one here, the color map name, again, this one you can use any map property color map. It can be anything. So I can change it maybe to cool warm. It should work as well. It's going to change the color to different map property color map. So now it looks like this. Right. So change it to whatever color map that you like. Next one, using a custom color map. So what does this mean? Because earlier we used the color map name here. So this is the parameter that we use. There's also another parameter for color map. So where can you find out like what we're using? Because under the hood, for all the rendering, we're using this one called TTyler. Okay. So TTyler is basically is the middleman. That think about here, the middleman. This is the data being hosted. So when we're trying to connect to this data set, it's use the middleman to render the tiles and then serve the tiles so that you can see that. So this TTyler is an open source project. You can check out the information in here. And the documentation, this is where we use basically cloud optimized GeoTIFF. So these are all the parameters available, okay? And earlier we used the color map name. So look at this one, Royal Tyler color map name. So that's why we use the tab 20 cool or something like that. But you can also provide a color map. Basically, this you can provide a custom color map. And this is what the next example I'm going to show you is how do we use a custom color map. For example, you might have some lane cover data. You want to give a custom color for the lane cover. So let's look at the result first, and then we can explain the source code, right? So you see here, this is a lane cover data set, the national lane cover database for the entire US. And if you zoom in, you should see a high resolution. So this is nationwide 30-meter resolution lane set data. And you can turn the layer on and off. You can zoom in and zoom out, right? And also the lane cover type here, there's a legend on the right, show you the lane cover data. And if you do remote sensing, you want to deal with lane cover data one way or the other. And so if you want to visualize that, you can use something like this. So all we need to do is to figure out where the data being hosted. So this file, again, is the one hosted on my GitHub. So I downloaded the file, I uploaded it. So this file is, I think, 1.5 gigabyte. It's compressed. If it's not compressed, this one is 25 gigabyte. So it's pretty big one because covering the entire US, 30-meter resolution. It's huge. And we're just visualizing the data on the fly. And you can provide a custom color map. So a custom color map is a JSON string with key and value. So this is the value, this will be the color. So for the lane cover data, it has different pixel values from 11, 12, 21, blah, blah. So each one represent a certain lane cover type. And this is the corresponding hex color code, okay? Hex color code. So what we're doing here, we add the color map, we create the map, we add the base map, the satellite base map, then we add the code layer, okay? Just passing the URL to pointing to the NFCD, and we passing this custom color map. If you don't pass it like this, I'm going to show you again. Without the color map, it's just pointing to the URL, and this is what it's going to look like. Like this. You probably have encountered this when you use QGIS, ArcGIS, right? You open raster dataset, it looks like grayscale. It's not very helpful. You always want to like give a different color, unique color for every pixel values. And this is why we want to use the custom color map. So if you provide a custom color map, it's going to render every pixel, depends on the pixel value, it's going to give you a different color. And so Leafmap also has this one called add legend. They can add the custom legend, the built-in legend, NFCD, and that's the one showing up here on the right, right? 11, 12, blah, blah, all the way to 95. And last one, add layer manager, is this one. So that I don't have to click the button. It adds this one by default. I can click the button, I can hide it, I can turn this one on, turn this off, change the opacity, and this one here is going to stay over here. So this is the legend. And if you want, you can actually inspect the pixel values. I think I have another examples later, but I want to show you how we can do that. So for example here, I can click this toolbar, and there's this one here, the identifier. So if I click this one, and then I can hover on my mouse on the map, if I click somewhere, you should be able to see the pixel value. I think right now the toolbar is like blocking the one. I can, let me not come out the toolbar. I can minimize it. There's a, let me see here, built-in laser, no, it's this one, right? Layer name, built-in legend. I forgot where it is. Anyway, so let me comment this one for now, just to show you, like you can use the pixel inspector to inspect the pixel values. So I'm zooming here somewhere, click this one, and if you click on the map, you see, getting the pixel values, 71. And for example here, you can look at the lane cover data. The red color is just urban, right? 24. And that's the laser that we saw you earlier. You remember 24, like high density, medium density, something like that. So if you need to inspect the pixel values, this is the way you can do that. You can actually, for example, you can collect training samples. So for example, this is urban. I can just, let me reset everything. So I can start from beginning. And for example, I can say, I can click a pixel here. And I can give this one a label. For example, urban. No, I think I need to give the label first before I click on that. Otherwise, it's not going to be. So, for example, class label, urban. And I click this one here. 1 pixel, another pixel, another pixel. So it's all 24, right? And then I can give another one. For example, water. I give you this here, water. And maybe another one here, water. And after that, I can download this one as a CSV. So it's going to show you the latitude and longitude. And then also give you a label. So if I download this one, oops. Interesting. I think something is wrong. I need to fix it. Oops. It's too fast. It's not supposed to clear it. Something might be anyway. There should be the link allows you to download it. I think it's just a bug. I need to fix it. Anyway, so this allows you to click training samples for doing lane cover classification. I already know after I fix the bugs. I didn't realize that it's not working right now. Okay, so this is how you visualize cloud optimized GeoTIFF. So if you have data somewhere, and then you can just stream the data. So this is basically show you how to watch movie from YouTube. Open a browser, type the URL, click play button, that's it. And then you can stream the data. And you can change the customization, change the visualization, change the color map to whatever way you want. So that's about cloud optimized GeoTIFF. The second one is local raster dataset. So you can download the data to a computer, and then you can also use Leafmap to visualize. For this example, I'm going to use a DM. For example, I download a DM from my GitHub. So you can use the Leafmap download file function to download any file from the internet. You can download a file from the HTTP URL. You can download a file from Google Drive. You can download it from anywhere. So you probably want to use this one if your source code involves some kind of getting data. If you develop a notebook, you want to send to somebody to use it. You don't want to write instruction. Okay, click the link and then download this file and then blah. You just write like one line of code. When you execute it, you will download the file automatically. So we're downloading this one, and then we can use Leafmap, add raster. So for vector data is add vector. For raster data is add raster. So again, it's basically just one line of code. Besides creating the map, display the map. How to display the raster is just add raster. So the add raster function here can handle data locally. It can also handle data on the internet. So right now, I'm just showing you, we downloaded the file, and right now this file here is DM90. So if you download that one to your computer, you should have the file somewhere on this one. For example, DM90 here. So you download this one to a local computer. And then we can use this. So you can provide a custom color map, right? So this is just the terrain color map. Like I said, you can change it to anything you like. I can change it to maybe jet. You see? You can change it to cool, warm. You can use any map, probably color map that you like. If the one doesn't exist, you're going to throw an error, and it will tell you it's only available. It's not available, so you need to change the value one. So because this is the DM, so usually you can just use the terrain color map to visualize that. Super easy. So just add raster and then pointing to your file path on your local computer, and then you can just visualize that. So for raster dataset, sometimes you might want to figure out, for example, what's the maximum pixel value, what's the minimum pixel value. So you can just call this leafmap.image min max, and it's going to show you, okay, the minimum value is 15 meter, maximum value is 4,338 meters. Okay, and the reason why you want to use this, because sometimes you want to add a color map or add a color bar to the map so that you can have a basically just like a legend. So we're going to set, for example, the color map terrain. So this should be the same one that you use to visualize the map. Then you can specify the Vmin and Vmax. So if I run this one, pay attention to the map above. It should not take too long, otherwise something is wrong. Okay, you see? Now I have this one here, upper right, right? Pretty nice. Just one line to code, add color map, and then just tell me what color bar do you want, minimum, maximum. Then you have this one. You can also make it vertical. So add color map, there's a parameter here, orientation. So if you want, you can change the orientation to vertical, but you might need to change the width and the height. Or you can also make it transparent. I'm not 100% sure if the transparent is working or not. It used to be working, but may not work anymore. I don't know. Okay, it's not working. So sometimes some other packages update the stuff and then it just breaks some of the functionality. But you can certainly, I think the vertical one should work. The orientation equal to vertical. And by default, it's going to add, looks like this. It's very weird because the width and height is basically reversed. So you need to change the width and the height so that the width may become smaller, the height becomes larger. So because by default, let me see here, the width is like 3, the height is 0.25, so we need to reverse it. So in this way, it should be what's that? Width equal to 0.25, height equal to 3, right? Then it should work. It might exceed this one, right? See? Right, so you can customize. You just need to figure out some of the correct parameters. And you can add a vertical one, you can add a horizontal one to whatever way you want. So that's about visualizing raster dataset on your local computer. And so the DM is just one single band, but you can also visualize a multispectral band. So for this one, I'm going to download another, for example, landscape imagery as 3 bands, and you can use the same thing, add raster. And I'm going to click this one. See, so now I have this one. So this one actually has more bands. So it should have 4 bands, red, green, blue, and also near infrared. So the reason, for example, over here, we use this one called indices. Earlier, when we used the ad hoc layer, you use the bands, but this one use indices. It's basically the same idea. The bands give you can provide a string of layer names. The indices basically provide the index of the layer. Index 1, so it starts from 1, okay? It's different from Python, they start from 0. So for here, it starts from 1, but it's using basically the raster IO convention. So 4, 3, 2 means we're using the band 4, band 3, band 2 to do the visualization. So band 1 is blue band, right? So basically near infrared, red band, green band. And that's why this is actually not RGB, okay? It's just a 4 color composite. So you have these 4 bands. So how do I visualize it using RGB? Red, green, and blue. What should we be putting in here? What's the indices for RGB? Okay, near infrared, green, red, green, blue, right? So the band 1 is blue. So if you want to visualize RGB, then you need to have red, green, blue. So what index is for red band? 3. And then green, 2. Blue, 1. So you expect to see this one just like natural color? Yes? Hmm?
Always like a set, like the is there always like a set way like the bands are gonna one always gonna
No.
okay.
It depends. So for example, I can download a landscape imagery that has 7 bands. I can extract just 4 bands. So you need to look into the metadata. It doesn't always mean that band 1 is blue. No, I can delete the blue band. So just like in Raster IO, right? You can open the data, you can open whatever band that you want, and you can save the data. So it's up to you. But in general, if the data are required by NASA, if they don't make any additional modifications, then the band 1 usually depends on the sensor. It might be blue, it might be coastal blue, it varies. So you need to look at the metadata, where you get the data from, and it may tell you what it is. But otherwise, you can download the data, you can explore it a bit, you'll be able to figure out. Okay, for example, you look at this one, this is certain RGB. And then because you use 3 to 1, so I can just figure out, okay, 3 is red band, 2 is green band, 1 is blue band. right? So if you're using 432, that means it's near infrared, red, green, and blue. Okay. So this is how you visualize data using different bands. And you can certainly pass in also the Vmin and Vmax. So the reason for this one is sometimes if the data set, the imagery looks a little bit dark and you want to stretch a little bit. For example, here, it looks fine, but there are certainly some cases when you open the imagery, it's just like pure dark. That means you might need to adjust the parameter. You might need to stretch a little bit. So if the image is too dark, you decrease the Vmax value. If the image is too bright, you increase the Vmax. So in that way, it's going to stretch. So for example, right now, what do you think about this imagery? Is it too dark or is it too bright? Too dark. So we want to make it brighter. So one thing you can do here, I can use the inspector here to click this one to look at the pixel values. Look at this. So the pixel values actually range from like 700, 1000, 1000, something like that, right? So this one, this water, the value is much smaller. And if you look at the vegetation, it should be a little bit higher. So suddenly you can see here B1, B2, B3. So those are basically the pixel, the value range of the pixel values. If you want to make it brighter, then you want to make your pixel values Vmax lower. But it should be a little bit larger than your B3 or something like that. So a little bit larger than your maximum value. So what we want to try here, for example, maybe you can change the Vmax to maybe 1300 to see what happens. So I say Vmax equal to 1300. And let's see if it becomes brighter or not. Yes? Is it brighter? This is probably too bright because the pixel value, anything greater than 1300 is going to be rendered as like very bright, basically white color. So this is probably too much. And maybe I change it to 1500. I guess it will be a little bit better. Is this a little bit brighter than what we have? It's okay, but this is still a little bit bright. But certainly it's better than the original one, just using the default parameters, right? So for example, I can maybe add the original data layer if I don't change anything. So in that way, you can see the differences. This should be maybe before, and this should be after, right? So I have two data layers. So in that way, you can see the differences. So this is what we have after, and see the differences. So this is how you can control the Vmin and the Vmax. So if it's too dark, you decrease the Vmax, but you need to figure out what's the rough value range of your imagery, and then you lower it down a little bit. Then that means anything greater than this bigger is going to be like white color. But if you change it to a really big, for example, I change this one to 10,000, what will happen? Is it becomes too dark or too bright? So think about here, from 0 to 10,000, but most of your value is like concentrated on the left side, and then your full spectrum is not fully utilized. That means your image will become really, really dark, because most of them like in the lower left side of the spectrum. See? Now it's totally dark. Yeah, it's normal, because when you're doing the visualization, it's from dark to bright, from black to white. So if all your value is very small, concentrated on the black side, it's going to be black. So that's why you don't want to make the value too big or too small. It needs to be just right, so that you give a good balance of your color contrast. This one is still too much, because most of values are greater than 1000. So that's why you get all of them are white color. So you need to play with it. But usually by default, if you don't add anything, it will give you a good balance, because it's using the 98 percentile, 2 percentile and 98 percentile. So usually they want to give you a good contrast in terms of visualization. Okay, and also you can inspect the pixel values. I think I already showed you. So you can add the map, add the raster, and then call this function add inspector. So you're going to add this inspector by default, and then you can click here on the map, and you can see all the pixel values like this. And again, you can also download this one. It doesn't work right now. There's a bug, so I need to look into that to fix it. But this is what you can use to visualize raster data and inspect pixel values. Questions? Is it easy? Right? It's easy. So now you know, like, oh, give me any vector data, give me any raster data. I can just, with 3 or 4 lines of code, it can visualize that for you. And it's reproducible because you don't need to tell them, okay, open the QGIS, ArcGIS, and then click this button, click that button. You just click this, run this code block. It will show you the imagery. And you can just share a Google Colab notebook. Anyone will be able to click the button. So this is about cloud optimized GeoTIFF. So essentially, it's just a GeoTIFF, but it's optimized for cloud retrieval visualization. And you can also download the file locally. You can visualize data on your local computer. So for the local raster dataset, under the hood is using a local type server. I'm not sure if I put the information in here. May or may not. Yeah, if I didn't, so basically it built on top of this one, local type server. So it's using this package to do the visualization. So the cloud optimized GeoTIFF, I use the TTyler. So in that way, that one is like middleman, so you don't need to install like additional packages. For local raster dataset, I use this one, basically is the backend. So this one is going to spin up the server to render the tiles. And you can directly use this one, but it's going to a lot more lines of code. Leafmap simplifies it. So just add raster, you don't have to handle all this by yourself. So it's much easier to deal with. So that's about cloud optimized GeoTIFF. There's another concept that you might encounter. It's called spatial temporal asset catalog. So this one is kind of a so-called specification. It's kind of a standard. You can think about it as a standard. It's a standard for organizing your geospatial data. So nowadays, a lot of data in the cloud is providing a spatial temporal asset catalog, so they can easily source the data, filter the data, something like that. I want you to basically give you this analysis. You go to YouTube, you're trying to search some video, right? You type that into the search box, it gives you the result quickly. And the reason for that is under the hood, there's a database of all the videos, and they basically do all the indexing. So it's going to figure out when this keyword is going to type to, for example, you want to find it, say, go to NASA. You want to find satellite data, let's say Sentinel. It's not random, okay? It's not like you put in all the files on a computer and then just randomly and then just use the Windows search bar to search the data. It's not that way, okay? Those are very unstructured data. So the spatial temporal educator is basically unstructured data. So basically, when you search, you're going to find out, because when we search geospatial data, usually we want to search by bounding box, by time. So for example, okay, I want to go to NASA, I want to search data covering Knoxville, Tennessee for last week or for last month, because I'm doing the flooding. I want to figure out what's the situation here before and after, right? So you need to figure out what's the bounding box for Knoxville, Tennessee. What's the time, date, and time range you want to figure out. And traditional database cannot handle that, because you can have the bounding boxes within the metadata, but there's no way you can figure out whether this imagery is covering this area or not. So you need to do basically some spatial analysis. So the spatial temporal educator basically have that kind of functionality. All you need is just tell me what area do you want, what's the date, and then you will return all the data that meet your criteria. And so spatial temporal educator basically a specification they can use to build up your, basically search through your database. And so it makes it much easier and efficient for users to query the data, figure out what imagery need to be downloaded, what result going to be returned to you. And it's basically just for geospatial data. So here, all the data, for example, for this one, if you click this spot satellite, there's some free spatial temporal asset catalog on the internet. And it's going to look like this. For the beginners, it's going to look very confusing. So for example, for this one here, it's going to show you the data catalog. So if you click this one, and inside, you're going to see the catalog, different files. If you continue to click inside, it's going to show you a bunch of this. And it's basically just a GeoJSON file. Under the hood, there's a raster dataset inside. There's a cloud optimized GeoTIFF inside. For example, now I click this one, I can actually zoom in. So the reason for this one is right now, if you see this one, it's just a long GeoJSON file. It's just like this. It's not a TIFF. It's not ending with .TIFF. It's just a GeoJSON file. So if I open this one, take a look. Under the hood, it looks like this. So this is called spatial temporal educator. It's basically encoding all the geospatial data in this GeoJSON file. And there's a file included beneath. There's actually the .TIFF something. So so basically the spatial temporal educator it contains cloud optimized GeoTIFF in that. So if you See this URL? This is the direct URL to the file. So if I copy this one and you paste this one to the URL, it should download the file if you hit enter. So take a look. See? And this one is only 7.6 gigabyte. So it's up to you. You can use the direct URL and then use map.add code layer. It should add the file. Or you can use the add stack layer. So in this way, you don't have to open the JSON file to see what's URL in there. You can directly just add code layer. And this layer, for example, it might has multiple files. So let me see if I can open this one here. Just to show you. So this one, it actually has multiple files inside. The code layer can basically it's multiple data layers inside. So we don't need to actually to deal with it directly, but I can use the leafmap.stack bands to look at this imagery. This stack catalog item has 5 bands, panchromatic, B1, B2, B3, B4. Okay, blue, green, red, and near infrared. So it's 4 bands and also a panchromatic band. And after that, you can just use this one, map.add stack layer. Okay. And similarly here, you can pass in the band you want to visualize, give a name, and let's take a look what it looks like. So what we're doing, basically we're streaming the data on the fly. We don't download the data. And this example shows you, right? So we have 2 data layers, the first color composite and also the panchromatic band. So we have 2 images. You can turn the layer on and off. You can zoom in to see. So when you zoom in, it's going to retrieve the tile. It's under the hood. It's cloud optimized GeoTIFF. It's still doing the HTTP range request. Depends on zoom level, depends on your area. It's going to download the tile and then put them together. Like right now, take a look. See here? Is you see the popping up the tile? You might see the outline roughly. There's some like vertical line. It's not perfect. So this is how it's merging together. It's a seamless imagery. But if your internet is very slow, you're going to see like it's showing up slowly. Right, so it's downloading the little small tiles, putting together is a bigger one. And so this is how you can visualize spatial temporal asset catalog. And it's very popular data specification. So you might encounter this one if you're doing cloud computing because you don't want to download the data. So all you need is I want to source some data and then I want to use that for data visualization. You can also do custom data catalog. So for there's some like 3D available data catalog out there, but you can also build your own data catalog. So for the next example, I'm going to show you, you can use custom stack catalog. And if you find any people, like for example, organization providing, okay, we provide a custom stack endpoint. That means they're providing some data, and then they have this stack catalog allow you to source the data by spatial and temporal. So basically by bounding boxes, by date timing range. So if they have, all you need is just a URL, and this is the name. So the name doesn't really matter. It can be any name. So this is equivalent to, okay, let me show you, give you an analysis. This will be like, okay, this is Netflix, and this is the URL to Netflix. And this one is Amazon Prime, and this will be the link to the Amazon Prime. So when you're searching a video, for example, I'm searching Titanic, then you can search different catalog. You can search this movie database, you can search the other movie database, and they're going to return the URL to that movie, and then you can watch that movie. So what we're doing here is, there are different databases. I want to search this database. Give me the data that meets that criteria, and then I can visualize the data. So next, let's take a look at this example. It's super easy. I'm going to create a map, and you can call this function called set catalog source. That means we can set the custom data catalog pointing to these two, and we can add the so-called stack GUI, and this is what it looks like. So I added this one, allows you to source data. And see the magic. This is equivalent to, there's a lot of free movies out there on the internet. And how do you actually watch a movie for free? So that you don't do worry about, okay, well, where do I download the data? I don't know where the data being hosted. Do I go to Google? Do I go to NASA? No, you can just try Leafmap. And just here, basically just 2 lines of code, pointing to the catalog, add the GUI. And so now let's see how we can download how we visualize some data. So assume, for example, okay, I'm doing maybe some mapping. For example, I want to map maybe some terrain, I'm doing some geomorphology, you can just zoom to anywhere you like. And then when it's pop up, so we have the element 84 Earth source data catalog. We also have the Microsoft Planetary data catalog. So we can use this one, we just use the first one. So all you need to do is just click this button, collections. So you're gonna figure out what kind of collections does this one have. So once you click the collections, look at this one. You should have this one showing up. So they have the COG, DM. They also have the Sentinel-2. I will show you later. So let's just do this, the first one. Okay. And after that, just click the items. It's going to retrieve all the data set covering this area. So then you should have all the bounding boxes. Do you see that? So you can see the bounding boxes for anywhere that you like. And after that, you can select the drop-down list. This is going to show you all the DM covering this area. So you can select whatever you like. And because it's DM, I can visualize using a different color map. So I'm going to use, oh no, why is this too many? So I'm going to use maybe the terrain. Okay. And after that, click this button, display. It's come up shortly. Hopefully not too long, but at least you can visualize the data without having to. There's a bug right now. I need to look into that. But take a look at this. So now I have a DM loaded on the map. I didn't need to download it. I just search. I want the data for this area. I want to look at the DM for this one. I want to visualize it using this color map. And you can zoom in. It's high resolution. It's 30-meter resolution. It's pretty good. When you zoom in, it's going to load the high resolution. And you can use all the toolbar that we have used, right? You can turn the layer on and off. I can change the opacity. It's right now under the hood is a cloud optimized GeoTIFF. And we didn't need to do anything. So this is source data based on your region, based on the time, right? So I can continue to do another one. I can select, for example, another one. Select the second one from the drop-down list. And I can just click the display button. It should load another one. So you can continue to just navigate through, find whatever data that you want. You can also download the data if you want to, right? So now you have this. You can try another one. Display. Okay. Of course, right now you see some artifacts because they're not using the same. The value range is not the same, so that's why you see some of the outlines. But if you want, you can download the data together, merge them as a single raster, or you can set the same vmin and vmax. Then you'll be seamless. You become a seamless data set. So I can turn, for example, the building, the footprint off. Then it will look like this. Okay. So this is how you can download some data, and you can try other data sets. For example, I'm going to reset. Again, there's something wrong. Let me run this one again just to show you. Now I can try a different data set. So I'm going to just do the collection again. So for this time, I'm going to show you how to source satellite data. So earlier we used the DM, but there's another one here called Sentinel-2, L2A. So this will be the satellite data. Sentinel-2 is for free, so it's 10-meter resolution. It's very high. And I'm going to zoom in to maybe somewhere here in San Francisco. And they say, okay, I want to do something on this area. So I select this collection, and then that's it. You can just click items. It's going to source all the data available in this area, covering this area. And then I can find out, for example, which one I want to visualize, right? So after you do the search, you should see all the items here from the list. These are all the data sets. It's similar to what you go to NASA or go to ESA, those website portals to download data. But you have to download the data to be able to integrate into your analysis. For this one here, you don't have to. I just see it. And I can add multiple data layers from different sources. So you have a lot more control. So for example, for right now, okay, I want to visualize this first one using RGB. And I have the red, green, blue. Just click the display. This, see what happens. See if it works. I hope you. And the file may be a couple gigabytes, you see. So now I have the lens data. Pretty nice. This is a very high quality imagery. And it's 10-meter resolution. So I don't have to go online to download like data. You don't have to search everywhere. You can just use this one to source data, visualize data. I can change the band combination. For example, I can change to maybe red, green, and blue. Red, green, blue. And I can give a, I think give a different name. Where's the, This should be a even anyway. So I can just load it again. Then it's render the data in different band combination, right? So right now this is RGB. See, pretty cool, right? No need to download data. So essentially, you can watch a lot of free movies, free geospatial data. Just a couple lines of code. As long as you know how to do that, super cool, super easy. You can find control about what you want. And the nice thing about this is not just visualization. So if you need to download the data, you need to access the search result. Here, I have a couple more functions in here they can access. So if you comment out this one, m.state.gdf, this one will return all the source result as a geodata frame, so that you can see, for example, how many were being returned. So I mean, Control Enter here. Look at this. So it's being returned as a geodata frame, so you can see all the data set covered in this area. What's the date? What's the platform? And resolution, for example, cloud cover. So you can do further data processing. So this one returns, for example, 20 data set. And you can also get access to the URL, all the links actually in here. If you really want, I can do it like this. I can actually visualize the footprint. So it'll be, so explore. ELORE. I'm not sure if it works or not. It may not. Because if there's some weird characters inside, it may not work. Looks like it's working. Okay. Because they're all covering the same area, so it's just all like dark blue. If you hover your mouse, you see all the attribute for each row. And do you see the geotiff? Oh, not the geotiff. The link is not there, but you can certainly see some URL in there. So this is basically all the original metadata information. So you can return the search result as a geodata frame, or you can return it as a dictionary. So the dictionary means like the name, you give me the ID, and then you're going to have the band, name, blah, blah, blah. You can open this one in text editor. So if you scroll down here on the right, take a look at this. Do you see some URL? And then we see some ending with TIFF. So under the hood, these are again cloud optimized geotiff. So you can choose to download it. The reason why we can visualize that on the map is because it's under the hood is cloud optimized geotiff. So we can render it directly. But if you want, I can click the link. You should be able to open this one up and it should allow you to download. So for example, I can click just one single band. How big is this one? 45 megabyte, one band. So you have like more than 10 bands. It's going to take you some time to download, but usually you don't want to download the data set. You can just visualize that directly. So this is how you can access the data result. You can also access as a state item. So it's up to you what you want to return. So anything that you do with the map, there's way to return to get the result. So you can either download all the data set, or you can just visualize that on the map directly. Okay, so that's about visualizing spatial temporal asset catalog. I know the name is a little bit lengthy, but that's what people come up with. That's what they use. And that's basically a way for you to construct your database so that people can source by geospatial, by date, by time, by bounding boxes, by geometry, and they're going to return the result intersecting with your meeting the criteria. And the last example I'm going to show you here is integrating AWS S3. So AWS stands for Amazon Web Services. So basically it's cloud computing platform. S3 stands for Simple Storage Service. You can think about Google Drive. It's same thing, but it's a different name, but they have API allow you to access. So there are a lot of free open access data available on the AWS Open Data. So if you want, you can go to just Google it, AWS Open Data. So they provide a lot of data for free, and it's on this local S3 bucket. But there's no direct link. They can just open and then download. You need to use the so-called client to download data. And there are a lot of geospatial data. So you can like AWS Earth data, Earth on AWS. So you can take a look at this one. They have tons of geospatial data on there. It's free, some are free, some are not. And so Leafmap allows you to actually render the data from S3 buckets. So you need to have some credentials. So probably for this one, for this section, you need to create an AWS account. So probably you guys don't have one, it's fine. You want me to use this one. But if you create the account, you follow instruction, then you're going to get the access key and ID, then you can render it. So if you are not doing that, if you run this code block, you're probably going to run into errors. That's fine. This one is bonus. Okay, this one is optional. You don't have to do that. But I'm just showing you, a lot of people have demand for this because they have some data on the AWS. They want to visualize, they want to source the data. So this one, the bucket name, basically the pointing to the URL, then this is under folder under that bucket. And basically it's just similar to Cloud Optimized GeoTIFF. You have the HTTP URL, you're pointing to the GeoTIFF file. So this one is going to show you, for example, under this bucket, this folder, it has these 10 files. And then I can just use the add code layer to render the file for free. So basically, I can render data from any cloud. For example, this is AWS, right? You see here, I can zoom in, I can zoom out. It's a nice high resolution data set. It's free. AWS makes up provide this one for free. So if you need to access data from AWS S3, you can use this one, the same things, but you do need to set the so-called API access key and also the secret. So basically, your username and password is just a way for you to gain access to the data. And the last example is so-called some of the bucket called request or pay. That means I provide the data, it's freely accessible, but if you need to use the data, you need to pay. So this is, you need to set this one, the environment variable called requester. That means I'm accessing the data, I want to pay the bill because AWS data itself is free. But if you want to use it, you need to pay AWS. The data provider doesn't need to pay. So sometimes some of the bucket might look offer in a way like this. And I can use, for example, just the add raster function. I can point into the data and it should load up. And this one is using the add raster function. So it might not be the most equation, but it's what you can see it's spinning. Do you see the data layer now? This is the one coming from the AWS cloud. And it's loading here on the map so I can visualize that. So if I click this one, you see this imagery, this one, you can zoom in, you can compare the data layer. Again, this one is not for everyone, it's optional. You don't have to try it, but for other parts, anything above the AWS S3, those things should be freely available for everyone. So you should be able to load the data from anywhere, okay? So from either the cloud or from a local computer. Okay, so hopefully by now, you are comfortable with visualizing data, geospatial data, vector data, raster data, using Leafmap. It doesn't matter what vector data format, you can just use add vector, it should handle the rest. It doesn't matter what raster you are using, just add raster, then you should be able to load the data. You can customize the color map, you customize the band, minimum value, maximum value, you can get the pixel value, you can get some metadata information. So most of the things can be done just within 2 to 3 lines of code. And that's all for today. So I will see you in the next lecture about 3D visualization. So it'll be even more fun next time.